All right, question 1, a circular measure style of question. The diagram shows a circle with center O and a radius of 5. Point A lies on the circle. Point B is such that this line is a tangent to the circle, and OB has got length of 13. Well, let's indicate on everything that we know. The radius is 5, so that's that length. We also know that this is a tangent to the circle, so that means the angle between the tangent and the radius must be 90 degrees by definition, so that's 90 there. And we know that the length from O to B is 13, so that length there is 13. And the first thing we're asked to find is the angle AOB. Well, the angle AOB is this angle here, right? So I'll label that on, we'll call that theta. Well, what have we got? We have got a right angle triangle, and we've got the adjacent side, and we've got the hypotenuse. So we can just write and say that cosine of theta must be equal to the adjacent 5 over the hypotenuse, which is 13. So theta is going to be the cos inverse of 5 upon 13. And we need to remember to have our calculator set to radians. So make sure you change your calculator mode. So I'm just going to do that now. How do I do that? Oh, wait. 1 second. Okay, got that done. So 5 divided by 13 equals, and the cos inverse of that equals 1.176. So I think I need to write it to 3 significant figures or 2 decimal places. So that'd be 1.18 radians. Okay, so that's the first part. That's part A. Second part is we want to find the perimeter of the shaded region. So the perimeter is going to be that length there, plus that length there, plus that length there. Okay, well, let's start by finding the length of AB. We have got a right-angled triangle, so we can use Pythagoras. So we can say that 5 squared plus AB squared is going to equal to 13 squared. So 25 plus AB squared is equal to 169. So AB squared is equal to 144. And that means that AB is going to be equal to 12. Right? So we now know that this length from here to here, that length, is equal to 12. Okay, then, what else can we do? We've got that length. How can we find this length? Well, we know that the whole length from O to B is equal to 13. And this length here is equal to 5. So this length here is going to be 13 minus 5. Right, so that length from there to there is going to be 8. So then the last thing we need to do is we need to find this arc length here, the arc length of the sector. And how do we do that? Well, we know that the formula is S is equal to R theta, where R is the radius, which is 5, and theta is the angle in radians, right, which is the 1.18. But I'll write it as cos inverse of 5 upon 13. Okay, then, so how do we find the total perimeter? The total perimeter is going to be equal to the 12 plus the 8 plus the 5 times by the cos inverse of 5 upon 13. So keep things exact, right? So I'm just going to type that into the calculator now. Okay, so times by 5 equals plus 20 equals, and I get 25.88. So I think I write that as 25.9. So 25.9 centimeters, right? Because we're using centimeters there. Okay, then the next one. How do we find the area of the shaded region? Well, what we could do is we could find the area of the triangle, and then we could subtract away the area of the sector. So how do we get the area of the triangle? So area of a triangle is equal to a half of the base times the height, right? And the base is 5 and the height is 12, right? Just to go over that, right? So base, this guy, height, that guy. Okay, so a half of 5 times 12, so that's 6 times by 5 is equal to 30. Okay, and then we could subtract off the area of the sector. Now, what's the formula for the area of a sector? It's equal to a half r squared theta, where theta is in radians. Okay, so we've got a half times by 5 squared times by the cos inverse of 5 upon 13. So what's the area of the shaded going to be? Well, it's going to be the area of the triangle minus the area of the sector. So we can say area shaded is equal to 30 minus 25 upon 2, the cos inverse of 5 upon 13. So let's try to do all that. So okay, so I'm going to times by 25, and I'm going to divide by 2, and I do 30 minus that. That gives me 15.299. So I'm going to write that there as 15.3 centimeters squared. Okay, so that's what I get for the area of the shaded region. Okay, question 2. We want to find the x-coordinates of the stationary points of the curve y is equal to this thing here. What is a stationary point? Well, imagine that we've got a curve, right? So here's our curve. A stationary point is a place where the gradient is 0, which means that we've got a maximum point or we've got a minimum point, right? So the gradient at these 2 points is 0, right? So we get a horizontal line for the gradient. So what do? Well, we differentiate, right? Because differentiation tells us the gradient of the tangent. And we will therefore know that at these stationary points, the gradient is 0, therefore dy dx will be equal to 0, right? So that's what we're going to do. We're going to differentiate the curve because differentiation tells us the gradient of the tangent. And we want to find where that gradient is 0. So we're going to find where dy dx is 0. Now, a second thing we've got to do is we've got to deal with the fact that this guy here is one function multiplied by another function, right? So we have the product of two functions, and therefore we've got to use the product rule. And that means we're going to call the first function u, so a half bracket 3 minus 2x. And we've got the second function, which we'll call v, is x plus 2 all squared. And we're going to need to differentiate both of these. Now, why is that? Because the rule for the product rule is dy dx, or y prime, is equal to v times by du dx plus u times by dv dx, right? So my notation there, right, the little dash means u prime, this is v prime, and it's a short way of saying du dx and dv dx. So I'm going to differentiate u, and I'm going to differentiate v, and I'm going to substitute it into the formula for the product rule. So if I differentiate u, this is like 3 upon 2, which differentiates to give 0. And this will be negative x, which will differentiate to give negative 1. Okay. And then secondly, how do I differentiate v? Well, I've got a chain rule because I've got one function, which is x plus 2 inside the bigger function of x squared. So how do I differentiate that? Well, I differentiate the big bracket. So I take the power of 2, bring it down to the front and reduce the power by 1. So I get 2 bracket x plus 2 to the power of 1. And then after that, I differentiate the function on the inside of the bracket. So I differentiate x plus 2, and that gives me 1, and I need to multiply by 1. Now, obviously, if we multiply by 1, nothing changes, but I think it's super helpful that you get into the habit of just doing this out of habit, really, because otherwise you may forget to do it in the case where this isn't 1. All right, so I'm going to substitute in now. So I get v, which is x plus 2 squared, times by u prime, which is negative 1, plus u, which is a half bracket 3 minus 2x, times by v prime, which is 2 bracket x plus 2 to the power of 1. And hopefully we can see that the half and the 2, they cancel off. So those are gone. And we should also notice that we have got a common factor of x plus 2, right? So we've got x plus 2 there and we've got x plus 2 there. So we can factorize out x plus 2, which is what I'm going to do. So I'm going to factorize out x plus 2, which means I've got an x plus 2 left over times by negative 1. And in this term here, I've got 3 minus 2x. Okay, so I'm just going to simplify the terms inside the big bracket now. So I get x plus 2, bracket, negative x minus 2, plus 3 minus 2x. And that simplifies to give x plus 2 times by, well, we've got minus x minus 2x, that's minus 3x. And minus 2 plus 3 is 1, right? So we could actually write it as 1 minus 3x is probably a better way of writing it, 1 minus 3x. Okay, so what do we want? The stationary points, right, are where dy dx is equal to 0. So I'm going to write that down. Stationary points when dy dx is equal to 0. Now, you probably think that me writing that is totally redundant and unnecessary, but it is such a good thing for you to do. You are always communicating to the examiner like what you're doing, what your method is. It also means that you don't, by default, set dy dx is equal to 0. So lots of students do that. They automatically do it, even when they're not finding stationary points. So I think it's just helpful for you that you clarify your own working. Okay, so we got 0 is equal to x plus 2 times by 1 minus 3x. And that's going to give us two solutions. Either x plus 2 is equal to 0, which means that x is equal to negative 2. Or we've got 1 minus 3x is equal to 0. So x is equal to 1 upon 3. So those are the two x coordinates of the stationary points. And that's what the question asks us to find. But of course, it's going to be helpful, isn't it, to find the y coordinate as well. So the function is y is equal to a half of 3 minus 2x bracket x plus 2 all squared. So when x is equal to negative 2, then what's going to happen? Well, we're going to get y is equal to a half bracket 3 minus 2 times minus 2 is plus 4. But then we've got negative 2 plus 2, which is going to be 0 all squared. So this guy here is going to be 0, right? So we've got one stationary point at negative 2 comma 0. And where's the other stationary point? Well, it's when x is equal to a third. So when x is equal to a third, then y is going to equal to a half, 3 minus 2 thirds, a third plus 2 squared. And let's simplify all of that. So we're going to get a half. 3 is 9 thirds minus 2 thirds. Okay. And where was I? 1 plus a third plus 2, isn't it? So that is 6 thirds, all squared. So this is going to be a half times by 7 thirds times by 7 thirds squared, which simplifies to give 7 cubed over 2 times 3 cubed. And I think there is a numerical value for that. Let me just try to calculate that. So we're going to do, was it 7 to the power of 3 divided by 27 divided by 2. So the numerical value for that is like 6.35. Okay, so we get that value there. All right, let's have a look at the next question. So part B, sketch the graph. Stating the intercepts with the coordinate axes. Okay, well, what you want to do, right, is whenever you're sketching a graph, even though you're not asked to, and even though it's only worth 3 marks, you basically want to know where the x-intercepts are, where the y-intercepts are, and where the stationary points are. So we're going to do that right now. We know that x-intercepts are where y is equal to 0. So we're going to solve 0 is equal to a half bracket 3 minus 2x x plus 2 all squared. So that's going to give us solutions at x is equal to 3 upon 2 and x is equal to negative 2. So those are going to be the two x-intercepts. It's also worth noting, right, that we've got x plus 2 squared. So that's like a repeated intercept, which means that the graph is just going to touch the x-axis at negative 2. And that, of course, is confirmed by the fact that we have got a stationary point at that point, right, on the x-axis. The y-intercept is where x is equal to 0. So we just substitute n, x is 0. So we get a half bracket 3 minus 0, 0 plus 2 all squared. So that gives us a half times by 3 times by 2 squared, which is 4. And so that's going to give us 6. And lastly, we've got the stationary points, but it's also good to know like roughly what the graph looks like. We know that this is going to be a cubic, right? Now, if we've got a positive cubic, then the graph is sloping upwards. And if we've got a negative cubic, then the graph is sloping downwards. Okay, now which one of these do we have? Well, if we were to expand this, right, this gives us an x squared term when we expand. times by negative 2x, we're going to get a negative x cubed term. So what we've got is we've got this guy on the right, the graph sloping down. So if I was to kind of sketch all this out, so I've quickly draw my axes, like that, draw like that, and let's make this like 1, 2, 3, I guess, 1, 2, 3. So negative. And we also know that we're going to intercept at 6. So I'll kind of exaggerate the scale of the axes a little bit. And what did we find out? We found out that we have got intercepts at 3 upon 2 and negative 2. So we've got an intercept here and here. That's 3 upon 2. So we're asked to label that, right? So we should probably just label that 3 upon 2. And we've got a y-intercept at 6. And what else? We had the stationary points, right? So we've got a stationary point at negative 2, 0. So we're going to have a stationary point here. It's going to be kind of like that. And we're going to have another stationary point at, what was it? A third and 6.35. Right, so a third is like here, and 6.35, I know, will be like there. So this will be another stationary point. So let me just label that on. That's the third. And that is the 6.35, or 27 cubed upon 2 times 3 cubed. So the graph kind of has got this shape, right? It's sloping down, touches the x-axis at that point, comes back up. Sorry that my graph doesn't look so neat and tidy. Goes through the y-intercept at 6, has a stationary point there, and then comes back down and crosses through the other x-axis intercept at 3 upon 2. Okay. All right, so that's that. Now part C, find the values of k for which the equation blah, 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 blah equals k has 3 real and distinct roots. Well, what does the line y is equal to k look like? It is a horizontal straight line, right? That's the line y is equal to k, and this could be, for example, y is equal to 3. And how many intercepts does that have? It's got 1, 2, 3 intercepts. So therefore, when this line, we find the intersection points with this curve, there are going to be 3 roots, right? So essentially, when we're solving this particular equation, what we're really doing is we're trying to find the intersection points of this curve and this line. So we've got 3 particular roots here. Now, what if we drew the line down here, right? Well, in this case, we're only going to have 1 intersection point. What if we drew the line here on the x-axis? Right, well, here we're going to get 2 intersection points because we've got 1 point there where it touches and another point here. What if we drew it up here? Right, well, there we've only got 1 intersection point. And what if we drew it here, right? Well, there we're going to get 2 intersection points, this point and where it touches there. So if we want to have 3 intersection points, we basically need to be above this minimum and we need to be below that maximum. So in other words, k needs to be greater than 0, right? So that the y value needs to be greater than 0, and it needs to be less than the 27 cubed upon 2 times 3 cubed, which is equal to 6.3 something, okay? And so that's going to be our answer. Remember that it needs to be greater than, not greater than or equal to, less than, not less than or equal to, because when it's equal to it, then we're touching at this point here, okay? Right, I hope that's helpful. Okay, question 3. Want to solve the equation 6x to the power of 3 upon 5 plus 1 is equal to 12 upon x to the power of 3/5. Well, this is basic substitution. We're going to say let u equal x to the power of 3/5. And so therefore, we can write this now as 6u plus 1 is equal to 12 divided by u. And if we multiply everything through by u, then that gives us 6u squared plus u is equal to 12. And so therefore 6u squared plus u minus 12 is going to be equal to 0. And this is a quadratic which should factorize, and we could use the quadratic formula or we could use a calculator because it's a calculator paper. But it seems to me that we'll have 3u and 2u. We want two numbers that are going to multiply together to give negative 12, but which are going to combine to give positive u. So I think if I make that 3 and I make that negative 4, that's going to work. Because 3u times by 3 is a positive 9u. And then this is going to be minus 8u, so we're going to get plus u there. So we end up with u is equal to 4 upon 3, or u is equal to negative 3 upon 2. And we remember that that u is equal to x to the power 3 upon 5. And so therefore we can just rearrange this and say that x must be equal to 4/3 to the power of 5 upon 3, or x is equal to negative 3 upon 2 to the power of 5 upon 3. And we just need to enter that into our calculator. So if I just do that just for 1 second, I get that the first one is, where is it? 1.62 to 2 decimal places. And the second one is going to be negative 1.97. Okay, negative 1.97. And so those should be my two answers. Okay, question 4, a combinations permutation style of question. A team of 10 players is to be chosen from 15 players. Find the number of different teams that can be chosen if there are no restrictions. Well, we've got 15 people to choose from. We're choosing 10. So that's going to be 15C10. Now, why is it 15C and not 15P10? Well, because combinations is when we are choosing 10 people from 15, and permutations, P, is when we are arranging 10 people from 15. And what's the difference between choosing and arranging? Well, when we are arranging, the order matters, right? We're putting people into an order. And when we're choosing, we don't really care about the order. We just want the people. So in this case, what's going on? Well, we don't care about the order in which we pick the people. We are just picking 10 people, right? So we're going to use combinations. And you can type in 15C10 into your calculator, and you should get 3003. So that's going to be quite an easy question. Okay, then next, the 15 players include 3 sisters who must not be separated. Find the number of different teams that can be chosen. Well, there are 2 ways to do this, right? If the sisters are in the team, right? So they are in the team, or if sisters are not in the team. Okay, so we got 2 different ways. Now, if the sisters are in the team, now let's just think about it. We've already chosen 3 people to be in the team of 10, right? So what we've got left is we've got 7 people to choose. But how many people can we choose them from? Well, we're not choosing them from 15 anymore because we're not going to choose the 3 sisters again. So actually what we've got is we've got 12 people to choose from, and we are choosing 7 of them. So that's going to be 12C7. And then if the sisters are not in the team, well, we need to choose 10 people, right? Because there are 10 slots left available. But we're not choosing from 15 because we want to make sure we're not choosing the sisters. We're choosing from 12, right? 15 minus 3. So that will be 12C, 10 ways of doing it. Okay, now then, we can either have the first situation or the second situation. So if we have got one situation or another situation, we are going to add, because these represent 2 different cases. So we're going to add 12C7 and 12C10. And I think I get 12C7 to be 792, 792. And 12C10, I get to be 66. So if you add up these 2 guys, you get 8, 5. Sorry, that's supposed to be 66. Do beg your pardon. A very bad looking 6 there, 66. And that will be 858. Okay, so that's what I get for part 2. All right, then part B, we've got a 6-digit number is to be formed using the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we've got 10 digits here. The 6-digit number cannot start with a 0, and all 6 digits must be different. Find how many 6-digit numbers can be formed if the 6-digit number is even. Well, I'm going to go through this in 2 ways. Okay, so I'm going to go through it a long way, and I'm going to go through it a short way. So long way first. We've got a 6-digit number. 1, 2, 3, 4, 5, 6. And this first digit, right, what can it be? Well, it can be anything apart from 0. So this guy can be 1, 2, 3, 4, 5, 6, 7, 8, 9, right? What about the last digit? The last digit, we want the number to be even. So this has got to be 0, 2, 4, 6, or 8. Okay, so those are the restrictions. Now, what I'm going to do is I'm going to cycle through the alternatives, and I'm going to cycle through the alternatives for the last digit, right? So the last digit can either be 0, 2, 4, 6, or 8. So watch as I do this. If the last digit is, okay, now if the last digit is 0, then how many ways could I choose the last digit? There's one way, right? Because I've got to choose 0. But if the last digit is 0, how many ways could I choose this first digit? Well, there are 9 ways, because I can have any one of these 9 digits. So I've got 9 ways of doing that. And then how many ways can I choose the 4 remaining? Well, let's have a think. I started with 10 digits. I've used up 2, so I've got 8 digits remaining. And now what I want to do is I want to have 4 of these, but I'm arranging them, right? They're not just choosing, I'm arranging them and putting them into order. So I'm taking 4 out of 8, I'm putting them in order, so that's going to be 8p4. So I get 8p4 there. Okay, well, what if the last digit was now 2? Well, how many ways could I choose the last digit? There's one way, because I've got to choose 2. Now, how many ways could I choose the first digit? Well, if I've already chosen 2, then I can't have 2 here. So that leaves me just with 8 digits in total. Right, so there are 8 digits I can choose for the first. And now I've got to choose the remaining 4 digits here. And again, that's going to be 8p4, right? Because I've got 8 digits remaining, and I'm arranging 4 of them, so that's going to be 8p4. And effectively, the same thing's going to happen, right? If my last digit is 4, there's one way of choosing the last digit. There'll be 8 ways of choosing the first, because I can't choose 4. There'll be 8p4 ways of choosing the middle 4. If my last digit is 6, there's one way of choosing that last digit, because it's got to be 6. 8 ways of choosing the first digit, because I can't have 6. And there are going to be 8p4 ways of choosing the middle. And the same thing is true with if the last digit was 8, there's one way of choosing that last digit, 8 ways of choosing the first, and 8p4 ways of choosing the middle. Okay, so these represent all the possible alternatives, right? So I can either have this situation, or this, or this, or this, or this. So what am I going to do? I'm going to add all these guys up. So I've got 9 lots of 8p4, plus 8 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 lots of 8p4. So how many lots of 8p4 have I got? Well, if I add them all up, I'm going to have 41 lots of 8p4, right? 41 lots of 8p4, because if I do 9 plus 8 plus 8 plus 8 plus 8, I get 41, right? So I get 41 lots of 8p4. Okay, and you could stick that into your calculator, and I think that gives you 68,880. Okay, all right then. Well, what's the other way of thinking through this question? Let's just move across to the right. I'm going to think of it a little bit like a Venn diagram. Okay, and so I'm going to talk about 2 different scenarios here. I've got event A, which is the number of ways, right? First digit is not 0. Okay, and B is the number of ways the number is even. Okay, and what do we got to understand? If I was to draw this out, so here's like my event A, and here's my event B, right? Then what are we saying? Well, event A, right, is every single number where the first digit is not 0. Now that includes numbers which are even, right, which would be here. And it also includes numbers which are not even, which would be here, right? These would be the odd numbers because they're not in the overlap region. And what does this thing represent, B, right? Well, this represents all of the even numbers. And that includes numbers where the first digit is not 0, but it also includes numbers where the first digit is 0, right? So if we want to kind of really kind of highlight this, right? This guy here, that represents all the numbers which are even. And this bit here in red is all the numbers which are even and have also got a 0 as the first digit. Okay, so what I want is I want to get this guy here, the overlap in the middle. Okay, so how can I think about that? Well, let's say we want to find the number of ways where we've just got an even number, right? And we really just don't care about whether or not the first digit is 0 or not, right? So we've got 1, 2, 3, 4, 5, 6 digits. Okay, so how many ways can I choose the last digit? Well, there are 5 ways, right? Because it's 0, 2, 4, 6, or 8, right? So there are 5 ways of doing that. And then how many ways can I choose the remaining 5 digits? Well, I'm going to have 9 digits to choose from, and I'm choosing 5, so that's going to be 9p5. Okay, so that's the number of ways even. So that's kind of like the green thing in my shaded bit. Okay, well, now what if I want to get the number of ways even and first digit is 0. All right, so that's going to like represent my red thing, right? So number of ways even and the first digit is 0. Well, how's that going to work? Well, how many ways could I choose my first digit there? Well, there's 1 because I got to choose 0. And then how many ways can I choose my last digit in that case? Well, think about it. I can't choose 0, right? So I can only choose 2, 4, 6, or 8. So there are 4 ways of doing that. And then how many ways can I choose the remaining 4 digits? Well, I've got 8 digits to choose from, and I'm arranging 4, so that's going to be 8p4. So this blue thing here, right? So kind of the overlap region is going to be 5 times by 9p5 minus 4 times by 8p4. Now, if we think about that very carefully, right, what's 9p5? 9p5 is 9 factorial over 9 minus 5 factorial. That's what it means. And 8p4 is 8 factorial over 8 minus 4 factorial, because that's what 8p4 means. So if I was to simplify this, I've got 5 times by 9 factorial over 4 factorial minus 4 times by 8 factorial over 4 factorial. And I can rewrite that 9 factorial. I can write it as 5 times by 9 times by 8 factorial, right? Because 9 factorial is the same as 9 times by 8 factorial over 4 factorial minus 4 lots of 8 factorial over 4 factorial. So hang on. I've got 45 lots of 8 factorial over 4 factorial. And I've got 4 lots of 8 factorial over 4 factorial. So what's that going to be? That's going to be 41 lots of 8 factorial over 4 factorial, which is the same thing as 41 lots of 8p4, which was the answer that we'd had over here, right? So it doesn't really matter which way you think about it, right? You can sort of organize it in your mind in different ways, and sometimes Venn diagrams might kind of help to get you to think what you need. But the point is, right, there are several different ways to think about these questions. And what you want to do is you want to be nice and clear and systematic in your own mind, right? You want to develop a method where you can sort of go through it logically and go, right, I need this, and therefore I need that, and just nice, clear logic. But also it's the case, right, if you're able to do a question in 2 to 3 different ways, then if the answer that you get is always the same, then you're really confident with yourself that you've actually got it right. So what I would encourage you is, as you're trying to think through these things, try not just to answer the question in one way, but to see if you can turn it around and answer it in a different way. And I think then your confidence is going to go through the roof, and you'll find these questions more doable. Okay? Okay, question 5, a straight line graph style of question when e to the y is plotted against x squared. A straight line graph with gradient of -3 is obtained. The line passes through this point. Find y in terms of x. Okay, well, a straight line has got the form y is equal to mx plus c. I've used big Y and big X here to distinguish it from e to the y and x squared. But of course, big Y is going to represent e to the y, and big X there represents little x squared. So what do we got? We got big Y is equal to -3 big X plus c, because we are told that the gradient is -3. We are also told that it passes through this point here, right? So when big X is 4.30, big Y is 5.85. So I can substitute into here. 5.85 is equal to -3 times by 4.30 plus c. And if I rearrange all that, I get that c is equal to 18.75. And so therefore I can write and say big Y is equal to -3 big X plus 18.75. And so therefore e to the y is equal to the natural log. Sorry, not the natural log. Sorry, e to the y is equal to, I'm getting ahead of myself, -3x squared plus 18.75, right? So in other words, I replace my big Y with e to the y and replace my big X with x squared. Now I can natural log both sides. So I get y is equal to the natural log of -3x squared plus 18.75. Okie dokie. All right. Then part B, find the values of x for which y exists. Okay, well, if we've got a natural log function, right, then the thing inside the natural log, or the argument, it's not even a natural log actually for any logarithm, the argument inside the logarithm must be greater than 0, right? This number here cannot be negative. It must be a positive number. So we're going to say we're interested when -3x squared plus 18.75 is greater than 0, which means we're interested when 3x squared minus 18.75 is less than 0. Now, we've got to be a little bit careful here, right? Because what we've got is we've got a quadratic inequality. So we don't want to just jump ahead. We're going to sketch a graph to make sure we truly understand what's going on. So I'm going to divide everything through by 3. And that's going to give me 6.25 here. And this can be factorized. And I think just make it a little bit more clear, right? This is 25 squared over 10 squared. Right, so we've got 625 over 100. Okay, so we want that to be less than 0. And so if I was to factorize this, this gives me x minus 25 upon 10 and x plus 25 upon 10. So what's this quadratic actually going to look like? It's going to look like this. Right, here's my quadratic. Right. It's symmetrical about the y-axis, so it's going to look like that. And the x-intercepts are going to be here and here. And what are those two values? 25 upon 10, or 2.5, and negative 2.5. Now, we want this quadratic. We want to find out when the quadratic is less than 0. Well, where is this quadratic less than 0? Everywhere here, right? Everywhere underneath the x-axis. Right, so we want these values. That's what we want. And so what values of x give us those values? Well, every value of x from -2.5 all the way up to +2.5. So in the end, if x is from -2.5 all the way up to +2.5, then y will exist. Okay? I hope that was helpful. All right, question 6. We're given a function here, ln of 2x squared plus 1 over x plus 2. We want to differentiate it. Okay, well, if we're differentiating this, we've got one function divided by another function, which means that we need to use the quotient rule. Okay, so we call the function at the top u, and we call the function at the bottom v. And hopefully you'll remember that the quotient rule is v du, so v times by u prime, minus u dv, so u times by v prime, all over v squared. Okay, so the key mistake that people make is that they get these two in the wrong way round, right? So instead of v du minus u dv, they do u dv minus v du. And the reason they've done that is often because they've memorized the product rule in that way, right? So what I suggest you do is, in order to help you memorize the correct order for this, you memorize the product rule also in this order, right? In other words, vu prime plus uv prime for the product rule. Okay, never mind that. Let's get on and actually do this. So I'm going to say that u is equal to the natural log of 2x squared plus 1. And v is x plus 2. And I need to differentiate these guys. So if I differentiate u, the natural log, right, the argument of the natural log, the thing that goes inside there, that goes onto the denominator. So that's 2x squared plus 1. And then I differentiate this term here. I differentiate the 2x squared plus 1, which gives me 4x. And I stick that straight onto the numerator. If I want to differentiate v, well, if I differentiate x, I get 1. And if I differentiate 2, I get 0. So v prime is just 1. Now, if this is all the case, then I can substitute straight into the formula for the quotient rule. So I get v, which is x plus 2, times by du, which is 4x over 2x squared plus 1, minus u, which is the natural log of 2x squared plus 1, times by dv, so times by 1, and then all divided through by v squared, so that's x plus 2 squared. Now, I think that it's a good idea to tidy up what we've got. So this guy is a fraction within a fraction, right? So we don't like that. So I want to get rid of that fraction. And the way that I'm going to do it is I'm going to multiply the entire numerator by 2x squared plus 1, which means, of course, I've got to multiply the denominator by 2x squared plus 1 as well. So if I was to do that, then I'm going to get here x plus 2 times by 4x, right? Because the denominator here, this term cancels off, minus 2x squared plus 1 times by the natural log of 2x squared plus 1. And then I am going to divide through by x plus 2 squared times by 2x squared plus 1, right? So that is my answer now that's nice and simplified. And I think that's all I've got to do. So let's have a look at part B. Given that x increases from 2 to 2 plus h, where h is small, find the approximate change in y. Well, okay, I think it's a good idea to explain what this kind of question is. So what we've got here is we've got an approximate change question. So what's going on with that? Well, let's imagine that we draw out a function. Okay, so I'm going to imagine drawing out one here. So we've got a curve. I don't know, the curve could look something like that. Okay, and so this is like y is equal to something, y is equal to some function of x. And what I've got here is I've got a point at point A, I'll call it. And I've got another point, which is a point here, that's point B. Okay, and the distance between these two, I'm going to say is delta x. In other words, there's just a little change in x that brings me from point A to point B, which I'll do it like this. All right, so it's just a little change in x that brings me from point A to point B. And also there's a little change of y. So I'll call that delta y. So what am I trying to say? I am trying to say that if B is very close to A, then there's just a little change in x that takes me to the x coordinate of B, and a little change of y that brings me to the y coordinate of B. Now, the gradient then from A to B, right, so the gradient from A to B is going to be equal to delta y divided through by delta x, right? Because the gradient is the change of y divided by the change of x. And so that's going to give me this line here, right, like that. Okay, like that. Okay, then, well, now let's say that I was to find the equation of the tangent or the gradient of the tangent at the point A, right? So the tangent's kind of like that. So that's the tangent at the point A. And how can I find the tangent? Well, I differentiate the curve, don't I? I find dy dx, and I find out what dy dx is at that point A. So I find the dy dx at the point A. Now then, if B is actually really, really close to A, then what's going to happen is that the gradient of the red line, the gradient of the tangent, is going to be the same thing as the gradient of the green line, right? The gradient between the points A and B. So what we can say is actually that delta y over delta x is going to be approximately the same thing as dy dx calculated at the point A. Okay, so in other words, the core thing really to understand is that so long as the distance between A and B is small, so we've got a little bit of x and a little bit of y, then the gradient from A to B, delta y over delta x, is going to be basically the same thing as the gradient at A, dy dx. So in this particular case, right, what's happening with our function? Well, x increases from 2 to 2 plus h. So in this particular circumstance, the x-coordinate of A is 2, and instead of increasing by delta x, right, they call that thing there h, right? So x is increasing by h. And what are we being asked to find? We're being asked to find the approximate change in y. So if I was to kind of rewrite all of this, basically what we're going to say is that the little change in y, delta y, divided by the little change in x, which is h, is going to be approximately the same thing as dy dx of our function at x is equal to 2. Okay, so I've got to substitute in x is equal to 2 into our differential here, right? So I'll take this guy and I will say when x is equal to 2, then dy dx has got to be equal to 2 plus 2, which is 4, times by 4 times by 2, which is 8, minus 2 times 2 squared. Well, 2 squared is 4, times by 2 is 8, plus 1 is 9, times by the natural log of the same thing, so the natural log of 9, all divided through by 2 plus 2 is 4, squared is 16, oh, sorry about that, times by, that's also 9, isn't it? Right, so hopefully now I can simplify all of this. So 4 times 8 is 32, minus 9 ln 9 all over 16 times by 9. Or, yeah, 16 times by 9. Oh, what is that? That's 160 minus 16, isn't it? Which is 144. Okay, so over 144. Okay. Okay, so if this is our answer for dy dx, then we just basically substitute it in over here. So we say that delta y over h is going to be approximately equal to 32 minus 9 ln 9. Ln 9. Sorry, I better write that a bit better, right? 9 ln 9 over 144. And therefore, delta y, right, is just going to be approximately equal to that whole thing times by h. I'm really sorry, I don't have a calculator on me, which is kind of bad. But if you put that into a calculator, I'm sure it will give you the value that will be in the mark scheme. Okay. All right. Let's go on to part C. Given that y is decreasing by 0.4 units per second, find the corresponding rate of change in x when x is equal to 2. Okay. Well, look, what does this guy here mean, right? Y is decreasing at 0.4 units per second. It means that the rate of change of y with respect to time, so we can write that as dy dt. Now, why do I say this is dy dt? Well, because we can look at this, right? This is units per second, right? So it's changing with respect to time. This is going to be negative because we are decreasing, and it's going to be negative 0.4, right? So dy dt, which is the rate of change of y with respect to time, is negative because we're decreasing 0.4. And I like fractions, so I'm going to write that as negative 2/5. Okay, well, we want to find the corresponding rate of change of x. Well, what does that mean? It means we want to find dx dt. Okay, that's the question. Well, how can we do that? Well, we basically use the chain rule. We say that dy dt is equal to dy dx times by dx dt. And how can we say that? How does that work? Well, because if we look at the right-hand side and we imagine that these are fractions, right? These are not fractions, but we're going to imagine that they are. Then we can cut off the x on both fractions, right? We're basically cancelling the x. And so what we're going to be left with, we're going to be left with dy dt. So in essence, what I'm saying is I've got dy dx, which was that thing we had earlier, 32 minus 9 ln 9. Right, so 32 minus 9 ln 9 over 144, right? Because that was the value of dy dx when x is 2. Yeah, because we're asked to solve when x is equal to 2. Times by dy dt, which is negative 2/5. Okay, and so again, you're going to have to type that into a calculator to get your answer. But whatever answer you get with the calculator, give me 1 second. I'll just go get it. 1 second. Okay, I'm back, and I've got 0.085 for the dy dx, and we're going to then times that by negative 2/5. So hang on, wait. Let's put it into the calculator. So times by. So I get that then to be negative 0.034. Okay. All right. So hopefully now you can understand how to do that question. So question 6, right, is kind of interesting. You've got to do a quotient rule, and they've given you an approximate change and the rates of change question in the same question. Okay, so question 7, it is given that f of x is 2e to the x plus a, where x is greater than 0, and g of x is equal to the square root of x minus 1, where x is greater than 1. We want to find the least value of a so that the function gf exists for all x's greater than or equal to 0. Okay, well, I think it's helpful if we just think about what gf actually means. Right, when we say gf, what we mean is g of f of x. In other words, we take the function f of x and we stick it into the function g. So on a diagram, this is going to look like the following, right? I start with my input variable x. That input variable gets put into the function f. And then the output of the function f is put into the function g. And that finally is going to give me my output, right? So when we say gf, what we mean is like this whole process here, right? So input goes into f, the output of f goes into g, and then g gives us final output. Now, what do we know? We know that the inputs to g must be x is greater than or equal to 1, right? That's what we know, okay? Because we're told here. So what does that mean? Well, it means that the outputs of f must also be everything greater than or equal to 1, right? Because imagine that we got an output to f which was like negative 2. Well, that's not going to work because I can't put it into the function g, right? So essentially what we're really trying to find is we're trying to find the situation where f will guarantee giving us values that are greater than or equal to 1. So in order to kind of demonstrate that, I'm going to draw out what the graph of f of x looks like, right? So we've got 2e to the x plus a. Okay, so if I was to draw out the graph of f, right, now hopefully you know that an exponential, right, basically looks like this. Okay, kind of looks like that. So that would be like the graph of y is equal to e to the x. And the key thing to sort of understanding it is understanding where the asymptote is, right? So in this case, it's the x-intercept, x-axis, sorry, and where the y-intercept is. Now, if we just go up to our graph here, right, 2e to the x plus a, right, where is the x, where's the y-intercept going to be? Well, it's going to be when x is equal to 0. So if I substitute in 0 into here, right, e to the 0 is 1. So I'm going to get 2 plus a. So my y-intercept will be 2 plus a. And so basically my intercept there will be 2 plus a. And the whole graph actually is going to be shifted up by a. But from our point of view, we're told that the function f is only defined for x is greater than 0 anyway, right? So basically, we can say, okay, the function f, right, y is equal to f of x, is going to look something like that, right? It's going to start when x is equal to 0 at 2 plus a, and it's just going to keep going up and up and up. Now, what do we require? we want all of the outputs for f to be greater than or equal to 1. So I'm saying that we want, just get rid of that, we want 2 plus a to be greater than or equal to 1, which means we want a to be greater than or equal to -1. Okay, so we are told in the question that a is an integer. We want to find the least value of a so that the function gf exists for all x is greater than 0. So that value is going to be -1, right? That is the least value of a that we can have if we want the function to exist. All right, then part B. So in the case where a is equal to 5, solve the equation f of x is equal to 3. Well, okay, well, I'm just going to redraw my diagram, right? Understanding what this composite function is, right? So gf of x means I take my variable x, I stick it into the function f, like that, and then I take that and I stick it into the function g, and then I get my final output. Now, in this particular question, right, what are we being actually asked to find? We've got a variable x, we stuck it through our composite function, and in the end we get 3, right? So 3 is the output here. So how can I find out what x is? All right, so how can I get x? Well, essentially what I'm going to have to do, right, is I would have to invert the function g, and that will give me some value. And let's call that value, I don't know, we'll call it p. And then we invert the function f, and that's going to bring me back to x. So I want you to try to understand the flow of this. The flow is basically saying, right, I've got a variable x, I stick it in the function f, and that gives me an output of, we'll call it p. And then I take p and I stick it into the function g, and I get an output of 3. So if I was to invert the function g, right, if I was to take 3, invert it, put it through the inverse function of g, I should get back to p. And then if I take p and I put it through the inverse of f, I should get back to x, right? So this is kind of like the core idea, right? So these functions here are going to be the inverse of g and f, right? So invert of g like that, and inverse of f like that. Okay, so we don't really need to actually even find the inverse, right? Because what could I say? I can take the function g, which is the square root of x minus 1, right? So g of x is equal to the square root of x minus 1. So what am I trying to say here? Well, I'm trying to say, well, if I put p into that, so if I find the square root of p minus 1, then that's got to be equal to 3. Right? Do people understand that, right? I put p into the function of g, so I find the square root of p minus 1, and the output of that's going to be 3. Okay, so I can therefore say that p minus 1 is going to be equal to 9, so p is going to be equal to 10. Okay, so that's all done. Well, then I can do the same thing for the function f, right? So f of x was equal to, what was it, 2e to the x plus a, I think? Yeah, 2e to the x plus a, and we're told here that a is equal to 5. So hang on, I've got my variable x, I stick it in the function f, and I should get the output of p. So 2e to the x plus 5 should be equal to p. And p we've just found is equal to 10. So we've got 2e to the x plus 5 is equal to 10. So 2e to the x is equal to 5. So e to the x is equal to 5 upon 2. And so x is equal to the natural log, write that a bit tidier, the natural log of 5 upon 2. Okay, so guys, I think really the key thing to understand is actually this diagram here, right? Understanding the composite function diagram, right? You've got one function going into another function. And so therefore to invert it, I've first got to invert g, and then after that, I've got to invert f. And if you really wanted to, what you could do is you could like calculate the whole inverse functions, right? And you could even calculate the composite inverse function. But look, this is 3 marks. So that's just so much work for 3 marks. Instead, I think the easiest thing to do is to say, let's imagine we've got this middle unknown variable that we don't know, right? Well, if I take x and I substitute it into the function f, I should get that variable p. And then if I take p and substitute into g, I should get 3. And then if you solve it like that, in other words, split it up into 2 parts, I think it's a bit simpler. Okay? All right. Question 8. Here we've got a trigonometric question. It's first an identity question. We want to show that sine times by tan squared theta over 1 plus tan squared theta can be written as sine cubed. Okay, I think the best thing here to do is to say that we know that tan theta is equal to sine theta over cos theta. I think that's the best thing. And therefore, what we can say is that our function, I'll call it, I don't know, left-hand side. Right, so we've got sine theta times by sine squared theta over cos squared theta over 1 plus sine squared theta over cos squared theta. And we got fractions within fractions, which generally speaking we don't like. So what we're going to do is I'm going to multiply the top and bottom by cos squared theta. So I do that and do that. And if I do this, then what am I going to get? I'm going to get sine cubed theta on the top, right? Because sine theta times sine squared theta is sine cubed, and the cos squared cancels off. And then on the bottom, what I'm going to get is cos squared plus sine squared theta. And what's cos squared plus sine squared? It's 1, isn't it? So I end up with sine cubed theta divided by 1, which is just equal to sine cubed theta. Oh, sorry, really bad handwriting there. Sine cubed theta. Okay, all right, part B. Hence we want to solve the equation sine 3x times by tan squared 3x over 1 plus tan squared 3x is equal to an eighth. Well, hopefully we can recognize, right, that this uses the identity from the previous question. So we can write this as sine cubed of 3x is equal to an eighth, right? Because basically, right, theta is equal to 3x, right? So it's the exact same thing. And so therefore I can cube root both sides, right? So I can say that sine 3x is equal to 1 upon 2, right? Because if I cube 8, I get 2, cube root 8 rather. And then I like to use substitutions if you don't mind. I know it's a bit overkill, but I'm going to do that. Let u equal 3x. So what am I trying to do? I'm now trying to solve sine u is equal to half. And I'm going to do this by using the unit circle. So let me draw out a unit circle for you. Unit circle is the circle of radius 1. So dun 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 dun, dun like that. Bum 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 bum. So here we got the circle of radius 1. And what is sine? Well, sine basically means the y coordinate on the unit circle, right? So if you're really not sure, when we say sine, we mean we're trying to find the angle where the y coordinate on the unit let me repeat that. Sorry, I messed it up. What does sine tell us? It tells us the y coordinate on the unit circle, right? So if I was to say something like sine 40 degrees, right? What I actually mean by that is, find the y coordinate on the unit circle when the angle is 40 degrees, right? So find out whatever that y coordinate is there. If I was to say sine of 10 degrees, right? What I mean is find the y coordinate when the angle is 10 degrees. If I say sine 50 degrees, it's find the y coordinate when the angle is 50. Okay, so that means that when we've got the equation sine u is equal to half, what it really means is we're trying to find the angle u where the y coordinate on the unit circle is equal to a half. Okay, so I want to find where the y coordinate is equal to half, which is going to be like there. Okay, so that's y is equal to a half. And that gives us 2 points, right? It gives us that point there and that point there. So what I want to do is I want to find the angle that brings us to that point and the angle that brings us to that point. Well, the angle that brings us to this point is going to be 30 degrees, right? We're using degrees in this question, so that's 30 degrees. And therefore, via symmetry, this angle here is also going to be 30 degrees, right? Which means that the angle here that brings me from the x-axis all the way to that point is going to be 180 minus 30, right? Because 180 brings me all the way around to there, and I've got to subtract 30 to get to there. So I've got that u is equal to 30 degrees, or it's equal to 150 degrees. But we can also say something else, right? We can say that if I was to take this point and I was to go round the circle, so if I was to go round 360 degrees, I'd get back onto the same point. So not only is 30 a solution, but also 30 plus 360 is a solution. So 390 is a solution. And 150 plus 360 is a solution, which is going to be 510 degrees. And we could also go the other way, right? We could subtract 360, right? So 30 degrees minus 360 is minus 330 degrees. And 150 minus 360 is minus 210 degrees, I think. Yeah, so yes, so 1 second. Okay, so these are our solutions for u, right? But actually we want to find solutions for x. So what is x? Well, x is equal to a third of u. So all I've got to do is I've just got to take these solutions and I've got to divide them by 3. So instead of 30 degrees, I've got 10 degrees. Instead of 390 degrees, I've got 130 degrees. Okay, instead of 150 degrees, I've got 50 degrees. Instead of 510 degrees, I've got whatever that is. Sorry, let me just use my calculator. My brain's a bit frying today. 510 divided by 3 is 170 degrees. And I could also do the others, couldn't I? I've got 330 divided by 3 is negative 110 degrees. And I've got negative 210 divided by 3. That's going to be negative 70 degrees. So what was I asked to find in the question? I was asked to find between negative 180 and positive 180, isn't it? Right, so I think that's going to be all the solutions there, because if I keep subtracting 360, then I'm going to be going out of bounds. Okay, all right, so I hope that was all helpful. Okay, question 9, which is a kinematics question. In this question, all lengths are in meters, time is in seconds. A particle P moves in a straight line such that t seconds after passing through a fixed point O, its displacement is given by this thing here. Now, by the way, when it says t seconds after passing through a fixed point O is defined as where the displacement is 0. And so we're measuring time after it passes through that point. So that's another way of saying that when t is equal to 0, s is equal to 0, right? So I think it's important just to understand that because a lot of students assume that, but they can't really interpret that thing properly, okay? All right, so find the value of t for which p is instantaneously at rest. Well, what does it mean instantaneously at rest? Well, if you're at rest, it means your velocity is equal to 0. Instantaneously means that you are at 0 for a split second. Now, practically, what does that mean? It means that the particle has changed direction. So if you imagine throwing up an object, right? So you throw up an object, it's going to look like that, okay? So it's going to be going up, 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 and then it's going to go down, 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 down. So as it's going up, the velocity is always going to be positive, right? We treat up as positive. And as it's going down, the velocity is always going to be negative, right? So positive velocity, then negative velocity. So what's going to happen at the top? Well, here at the top, the velocity's got to be equal to 0. Yeah, because it's gone from positive to negative. But it's not like 0 and then staying still, right? It's kind of like just 0 for a split second, right? Positive, negative. So this is what we mean by instantaneously at rest. We really mean that it's changing direction. And that's important to understand because that fact is going to be relevant later on in the question. Okay, so we want to find velocity. Velocity is the rate of change of displacement. So we are going to differentiate this expression here, s. Okay, so if I differentiate the ln, I get 2t plus 1 on the denominator. I then, because that's the argument of the ln, I then differentiate that argument, 2t plus 1, and that gives me 2. So 2 goes on the numerator, right? So that's me differentiating the natural log. And if I differentiate 5t, I just get 5. So this guy is equal to 10 over 2t plus 1 minus 5. Now, we know that it's at rest when v is equal to 0. So therefore, we're trying to solve 0 is equal to 10 over 2t plus 1 minus 5. So 10 over 2t plus 1 is equal to 5. So 10 is equal to 5 times by 2t plus 1. I'll divide through by 5. So that's equal to 2 is equal to 2t plus 1. So 2t is equal to 1, which means that t is equal to half. Half, or if you prefer, 0.5 seconds. Okay. All right, then, part B, we want to find the distance that p travels between 0 and 2. Well, hang on, wait a second. We've just figured out, haven't we, that the particle changes direction when t is equal to a half, right, which is somewhere between 0 and 2. So what's happening? We know that the particle is going to be moving, let's say, in one direction. Then when t is equal to a half, it's going to be moving in another direction. So if I want to find the distance, right, I've got to know how much it goes forwards and also how much it goes back. So that's what we've got to do here. So we are going to have to find the displacement. So we want to find displacement when t is equal to 0, when t is equal to a half, and also when t is equal to 2, right? We want to know where it is when it starts, where it is when it changes direction, and where it is at the end. Well, when t is equal to 0, we already know that the displacement is equal to 0, right? We're told that in the question, but if you're really not sure, right, s is equal to 5, 2 times by 0 is 0, plus 1, 5 times by ln 1, beg your pardon, minus 5 times by 0, which is 0. Well, ln 1 is 0, so this is just 0. Okay, so that we already know. What about when t is equal to a half? Well, then the displacement is going to be equal to 5 times by the natural log of 2 times a half, which is 1, plus 1 is 2, minus 5 times by a half, so that's minus 5 upon 2. So we're going to get a value there. Now, I think I probably need to key that into a calculator to figure out what that is. And I get 0.96. Okay, so I get 0.96 there. Okay, then what I want to do is I want to find out when t is equal to 2. So if I find when t is equal to 2, then s is going to equal to 5 times by the natural log of 2 times by 2, which is 4, plus 1 is 5, minus 5 times by 2, so that's minus 10. And so this guy is going to be equal to negative 1.95. So let's try to figure out exactly what this means. I'm going to draw a diagram like this. And I really think the diagram is such a helpful thing. So this is going to measure my displacement. And here's the origin point, right? That's where we start. So when t is equal to 0, right, we're there. And then what happens at t is equal to half? Well, when t is equal to half, we're at 0.96, right? So let's say that's here. So this is where t is equal to 0.5. And the displacement there is 0.96. And then where are we going to be when t is equal to 2? We're at negative 1.95. So this is t is equal to 2. And the displacement there is going to be negative 1.95. So the path of the object, right, is it goes from here to here. It's going forward. And then after that, it's going backwards, like that. Right, so the object starts by moving forwards, and then by moving backwards. So what's going to be the total distance? Well, the total distance is going to be this distance here plus this distance, which is going to be what? It's going to be 0.96 plus another 0.96, right? Because I've got it going there and coming back, plus the 1.95, right? So I got 2 lots of that distance plus 1 lot of this distance. So I'm going to write it out as natural logs, I think, just to make it nice and plain. So the distance is going to equal to 2 lots of the 5 ln 2 minus 5 upon 2. Plus this distance here, right? But I want to make it positive. So how can I make it positive? Well, I could times it by negative 1, I guess. So negative 1 times by 5 ln 5 minus 10. Right, I hope you understand why I'm making it positive, right? Because negative just means direction, right? Negative means I'm going to the left, but I'm interested in distance, so I just want that to be a positive number, right? So I've just times by -1 to make that value there a positive. And so this guy will become, what will it become? 10 ln 2 minus 5 minus 5 ln 5 plus 10. So I get that to be 5 plus 10 ln 2 minus 5 ln 5. Right, and that should basically be the same thing as 2 lots of 0.96 plus 1 lot of 1.95, and that should be your final answer, whatever it is. Okay, part C, we want to find an expression for the acceleration at in terms of t. Well, acceleration is equal to dv dt, right? It's the rate of change of velocity. So we've just got to differentiate velocity, and our equation for velocity was, where was it? 10 upon 2t plus 1 minus 5, right? So we're going to differentiate 10 upon 2t minus 1. Right, so I'll write it over here. Sorry about that. So v is equal to 10 upon 2t minus 1 plus 5. 2t plus 1, beg your pardon. And I can rewrite that as 10 bracket 2t plus 1 to the power of -1 plus 5. And so therefore, if I differentiate that, I can differentiate it using the chain rule. The -1 comes down to the front. So I've got -10 bracket 2t plus 1. I then reduce the power by 1. So that becomes -2. I differentiate inside the bracket. So if I differentiate 2t plus 1, I get 2. So I multiply through by 2. So this becomes -20 over 2t plus 1 squared. Okay, so just to reiterate what I've done there, that is a chain rule. I take the -1, bring it down to the front, reduce the power by 1, differentiate inside the bracket, and multiply through. Okay? So D, we want to find the acceleration when t is equal to 4.5. Okay, we'll just come back to here. So when t is equal to 4.5, which is 9 upon 2, then the acceleration is going to equal to -20 over 2 times 9 upon 2, which is 9 plus 1 all squared. And 9 plus 1 is 10. 10 squared is 100, so we get -20 upon 100, which is going to equal to -0.2 meters per second squared. Okay, so I think that should be a fairly straightforward question there for the end. Okay, question 10, which is a binomial expansion type of question, and it's worth 10 marks. There's a lot on offer here. So we've got the expansion of ax minus 2 to the power of 4 times by 1 plus b upon x to the power of 3 is written in descending powers of x. In other words, the powers are going to get smaller. The first three terms of this expansion are blah, blah, and blah. It is given that a, b, and c are positive integers. Find the values of a, b, and c. Okay, so essentially what we got to do is we need to expand both of these. So I'm going to start by expanding ax minus 2 to the power of 4. And I prefer to write that as ax plus -2 to the power of 4. And if you follow my videos before, you'll see that the way I do it is say that the powers of ax are going to decrease and the powers of -2 are going to increase, right? So we're going to get ax to the power of 4, ax to the power of 3, ax to the power of 2, ax to the power of 1, and ax to the power of 0. And we're going to have -2 to the power of 0, -2 to the power of 1, -2 to the power of 2, -2 to the power of 3, and -2 to the power of 4, right? So what you should notice is the powers of this decrease, 4, 3, 2, 1, 0, and these increase 0, 1, 2, 3, 4, okay? Then the last thing I've got to include is I've got to include the coefficients, which will be 1, 4, 6, 4, 1. And you can either get those coefficients by using Pascal's triangle, or you could get them by using the C function on the calculator. This will be 4C0, 4C1, 4C2, 4C3, and 4C4. Okay, so now what I'm going to do is I'm going to try to simplify this. So I'm going to get here a to the power of 4, x to the power of 4, because -2 to the power of 0 is just 1. Then this is going to be 4 times by a cubed x cubed times by negative 2 plus 6 times a squared x squared times by positive 4, right? Because negative 2 squared is positive 4, plus 4 times by ax times by negative 8, right? Because negative 2 cubed is negative 8, plus 1, because ax to the power of 0 is 1, times by 16, because negative 2 to the power of 4 is 16. So if I simplify this, I get a to the power of 4, x to the power of 4, minus 8, a to the power of 3, x to the power of 3, plus 24, a to the power of 2, x squared, minus 32, ax, plus 16. Okay, so that's the first one. Then I've got to do 1 plus b upon x cubed. So I've got to do 1 plus b upon x all cubed. So I'm going to apply the same thing, right? Powers of 1 are going to decrease. 1 to the power of 3, 1 to the power of 2, 1 to the power of 1, and 1 to the power of 0. And the powers of b upon x are going to increase. So b upon x to the power of 0, b upon x to the power of 1, b upon x to the power of 2, and then b upon x to the power of 3. And then lastly, I've got to put in the coefficients 1, 3, 3, 1. And again, you could do that using Pascal's triangle, or you could use NCR, right? This would be 3C0, 3C1, 3C2, and 3C3. So now I'm going to simplify this again. I'm going to get 1, because 1 cubed is 1, b upon x to the power of 0 is 1, plus 3 times by b over x, plus 3 times by b squared over x squared, plus b cubed over x cubed. All right. And, you know, I've got to really multiply these two together. Now, I mean, what you could do is you could say, all right, well, I want to find the terms that are going to give us an x to the power of 4. So I could say, okay, well, I'm going to have that term there times by 1. That will give me the x to the power of 4. But, you know, all in all, if you were to ask me, I think I might just expand the full thing. Yeah, I know it's a bit long and it's a bit boring, but I think it's probably the safest. So I'm going to do a to the 4, x to the 4, minus 8a to the 3, x to the 3, plus 24a squared, x squared, minus 32ax, plus 16, times by 1 plus 3b over x, plus 3b squared over x squared, plus b cubed over x cubed, like that. And what's that all going to be equal to? Well, remember that I'm only interested in terms that go from x to the power 4 to x to the power 2, right? So I can just ignore terms that don't work out. So this term times 1 is a to the 4 x to the 4. And then this term times by 3b upon x, right? Well, I'm going to get plus 3a to the 4b x cubed, right? Because x to the power 4 divided by x is x cubed. Then I'm going to get this term times by that, which is going to give me 3a to the 4 b squared x squared. And then if I then do this term times by that, I'm going to get an x to the power of 1, and I'm not interested in that, right? So I can just ignore. So then next, I'm going to take this negative 8a cubed x cubed, and I'm going to times it by 1, which will be, let's get rid of that, negative 8a cubed x cubed. And then I'm going to take this term, I'm going to times it by 3b upon x, which will be negative 24a cubed b x squared, right? And then I don't need to multiply this by that because that will give me an x term, and I'm not interested in those. So then the last thing I've got to do is I've got this term here, I times it by 1, which will give me plus 24a squared x squared. And again, I'm not interested in doing this term times by that because it'll give me an x term, and I'm not interested. So then, what do I want to do? Well, I want to group together all the terms. So I've got an a 4x to the 4. Now, what x cubed terms do I have? Well, I've got that and I've got that, don't I? So I can write this as plus bracket 3a to the 4b minus 8a cubed, x cubed. And let's write the x squared terms. I got that guy, and I've got that guy. So that's going to give me 3a to the 4b squared minus 24a cubed b plus 24a squared x squared. Well, I hope that's all right. Did I miss out a b there? No, I didn't. Okay. All right. All right. So what are we told in the question? We are told that ultimately we get 81 x to the power 4, 999 x to the power 3, and c x squared. So we know that the coefficient of x to the 4, right, is going to be equal to 81, right? So this guy here, that's got to be equal to 81. So we compare the coefficients of x to the 4. A to the 4 is going to equal to 81. So a is going to equal to 3. Okay, so we got that. Then we can compare coefficients of x cubed, right? And we know that the coefficient of x cubed has got to be equal to 999. 999. So this term here has got to be equal to 999. So 3a to the 4b minus 8a cubed is going to be equal to 999. Well, let's factorize out the a cubed, I think, right? So we've got a cubed bracket 3ab minus 8 is going to be equal to 999. And a is equal to 3, isn't it? So 3 cubed. So we've got 3 cubed here. Times by 3 times by 3, so that's going to be 9. 9b minus 8 is equal to 999. Well, how can I write 999? I can write that as 3 times by 111. And I think 111 can also divide by 3, can't it? So that would be 37, I think. So that would be 3 times by 37. Is that right? So then, if I divide that, what am I going to get? I can cancel off 3 squared, can't I? So that goes, and that goes. So I've got 3 times by 9b minus 8 is equal to 37. Oh, that makes me suspicious. I suspect I've gone wrong there somewhere. Where have I gone wrong? Wait, I've gone wrong here. That's that's 3 squared, isn't it? Right. Sorry about that. Let me just explain that again. 999 is 9 times by 111, which is 3 squared times by 111, and 111 can be factorized as 3 times by 37. So all of those 3's cancel off. Right. Gone. So I've got 9b minus 8 is equal to 37. So 9b is equal to 45. So b is equal to 5. Okay, so then lastly, I compare the coefficient of x squared. So that's going to give me 3 times by a squared. So 3 times by 2, sorry, a to the power 4. 3 times by 2 to the power of 4. Oh, shoot. Let me, sorry, guys. A is 3, isn't it? So we've got 3 times by 3 to the power of 4 times by b, which was 5. So we've got 5 squared. Minus 24 times by 3 to the power 3 times by 5 plus 24 times 24 times by a squared, which is 3 squared, is equal to c. Okay, well, I did everything else without a calculator, but I don't think that's doable without a calculator. I'll be really honest. I'll just try. I think it's good to practice it. So that's 3 to the 5 times 5 squared. 24 is what? How can I factorize that? That's 4 times by 6, isn't it? Times by 3 cubed times by 5. plus 4 times 6 times by 3 squared is equal to c. So 3 to the 5 times by 5 squared minus 2 squared times by 2 times by 3. So it'll be 3 to the 4 times by 5 plus 2 squared times by 2 times by 3. So it's 3 cubed. It's equal to c. So I think I can factorize out 3 cubed. So that's 3 squared times by 5 minus 2 cubed times by 3 times by 5 plus 2 cubed times by 1 is equal to c. So that's going to be 3 cubed. 9 times by 5 is 45. That is going to be 8 times by 3, which is 24, times by 5, 120, plus 8 is equal to c. So I've got 3 cubed, which is 27. 120 minus 45 is what, negative 75, plus 8, negative 67, I think. It's equal to c. I will use my phone calculator just to check my numbers. So 45 minus 120 plus 8, negative 67. Now I'll times that by 27. So C I get as negative 1809. Okay, well, as I said, guys, I don't have my calculator on me at the moment, so it's possible that I've made a small slip there, and if so, I'm really, really sorry about that, but I'm trusting that you guys have got calculators, you can do it. So I'm very confident that A is 3 and that B is 5, and I hope you understand the method that I've used. So just check the last number at the end, but by my calculation, it's negative 1809. Okay, question 11. We want to solve the equation cot y plus 1.5 is equal to 3, where y is in radians and y is between 0 and 6. Now, the first thing I would do with a question like this is we've got this thing here, y plus 1.5. I'm going to use a substitution. Let's call it x equal to y plus 1.5. So now what we're trying to do is we're trying to solve cot x is equal to 3. Now, what is cot? Cot is 1 divided by tan. And the way we know that is we always look at the third letter, right? So 1, 2, 3, the third letter is T. So this is 1 divided by tan, right? And if you think about sec, the third letter is C, so it's 1 divided by cos. And cosec, the third letter is S, so it's 1 divided by sine. So what we've got here is we've got 1 over tan x is equal to 3, which means we're trying to solve tan x is equal to a third. Okay, now at this point we want to try to understand what is sine, what is cos, and what is tan. Okay, and I think the best way to do that, we can either look at a graph or we can use the unit circle. I'm going to lean into the unit circle in this case. Okay, so a unit circle is the circle of radius 1. Like that. Like that, like that, like that, like that. Oh, dear. Okay. And what I want you to do is I want you to imagine that we've got a point that is on this circle. I'll call it the point P. And that point has got an x coordinate and it's got a y coordinate. And that point also makes an angle of theta with the x-axis, right? So it's a circle of radius 1 with a point on that circle that makes an angle with the x-axis and has got an x and a y coordinate. Now, the whole point is, right, imagine that I take this point and I rotate it all the way around the circle, right? So as I rotate it around the circle, the angle of theta is going to change, but also the x and the y coordinate is also going to change with it, right? So if my angle is 0, that means I'm here. My x coordinate is 1 and my y coordinate is 0. Whereas if my angle is 90 degrees or pi by 2, my x coordinate now is 0, my y coordinate is 1. Now, what does this mean? It means that the x-coordinate is a function of the angle, and the y-coordinate is a function of the angle. And we can say the x-coordinate function is defined by cos, and the y-coordinate is defined by sine. Right? So when we say cos and sine, what we actually mean is the functions that tell us the x-coordinate on the unit circle and the y-coordinate on the unit circle. That's what we mean. So that, therefore, like what is tan, right? Because we haven't defined tan yet. Well, imagine that I want to find the gradient between the origin and this point here, right? Well, that distance there is going to be the y coordinate, and that distance there is going to be x coordinate. So the gradient from O to P is going to be equal to the rise, y, divided by the step, x, which is sine theta over cos theta, right? Because y is the sine and x is the cos, and that's equal to tan theta. So if you're wondering, like, what is tan? Tan tells you the gradient from the origin to your point, right? So let's recap. Cosine tells you the x coordinate of this point. Sine tells you the y coordinate of this point, and tan tells you the gradient. Okay, so when we're trying to solve tan x is equal to a third, we're trying to find the angle x where the gradient is equal to a third on the unit circle, right? That's what we're actually trying to do. And if we were to extend this idea, like, where else on this circle is the gradient going to be equal to a third? Well, if I just extend the line, right, like that, so I keep that as a straight line, right? Then over here, the gradient from this point to the origin is also going to be a third, right? And that's going to be separated out by an angle of 180 degrees or by pi radians, right? So what I can do is I can find my first solution. So I find x is equal to whatever it is, the tan inverse of a third. So let me just try to compute what that value actually is. Tan inverse of a third is 0.322. Okay, 0.322. 0.322. And then to get to the next solution, right, I just add pi radians. And then to get to the next solution, I can add another pi radians, and then another pi radians, and another pi radians, and another pi radians. So in other words, all of my solutions are going to be 0.322 plus or minus multiples of pi. Okay, so that's my solution there for x. Well, I didn't want to get a solution for x. I want to get a solution for y, right? So if x is equal to y plus 1.5, y is equal to x minus 1.5, right? So y is going to equal to x minus 1.5. So what are we going to have? We're going to have 0.322 plus or minus multiples of pi minus 1.5. So if I do 0.322 minus 1.5, let me just stick that into the calculator. 0.322 minus 1.5, I get negative 1.18. Okay, so negative 1.18. And I've just got to add to that plus or minus multiples of pi, right? So I want solutions between 0 and 6, don't I? So I'm not interested in negative 1.18. But if I was to add pi to that, then what I'm going to get is 1.96. And then the next solution, if I add another pi, is 5.10. So 1.96 and 5.10, 1.96 and 5.10. Those should be my two solutions within 0 and 6. Okay, so I hope that's helpful, guys. I think you'll notice in my earlier papers, right, I used to draw the graphs of sine and cos a lot more. But now what I'm doing is I'm leaning more hard into the unit circle, because I think it's probably, on retrospect, it's a bit of an easier way to do it. But you really need to understand this concept that what is cos, what is sine, and what is tan, they're all related to this circle. Cos is the x coordinate, sine is the y coordinate, and tan is the gradient, right? If you can understand that, then I think you're going to be able to do these questions a lot better.